Okay, let's pick up in this second video with the different components of returns. For many investments, there is a current portion of the return, which we'd call an income component, as well as an appreciation portion, or sometimes called a capital gain portion of your return. So if we think about a few different investments, we can see this in action. With stocks, we would have something called a dividend yield. That's going to be equal to the dividend income that you have over the course of a year. If we divide that by the stock price, we get a yield measure. Alternatively, we can do the capital gain. And this is just, it looks, well, it's simpler than it looks perhaps. We got P1 minus P0 all over P0. That's saying the price at the end of the year minus the price at the beginning of the year, all divided by the price at the beginning of the year. This gives you a percentage change in price over the course of a year. Of course, it could be a different time period, but usually we're going to be measuring returns over the course of a year. So if we put the dividend yield together with the capital gain, we would have the total return for a stock. Likewise, with a bond, we have some current income. It's called the current yield. That's how we measure it. It's going to be equal to the coupon payments for a bond over the course of a year, divided by the bond's price, how much we invested in the bond at the start of the year. The capital gain, just like with a stock, is going to be the ending price minus the beginning price. Take that difference all divided by the beginning price, and we would have a percentage change in the bond's price. So hopefully that's gone up in value. We had a capital gain on our bond, as well as some bond income. We put those two things together, and we have our total return for the bond. Now with real estate, we again have these two pieces, these two portions of a total return that we care about. A current yield is going to be equal to the cash flow that the real estate spits out, the cash that's going out to the owners. We're going to divide that by the value of the real estate at the start of the year. And then secondly, the capital gain is going to be now the value at the end of the year. Subtract out the value at the beginning of the year. So we'll have this increase in value. Again, hopefully an increase. You can certainly have capital losses. Of course, that's not why people typically invest. But the capital gain would be the increase in value over the course of the year, and we would divide that by the beginning of year value to get a percentage change. So those are the components of returns. That's what makes up the total return that an investor would enjoy. So both a current portion and then an appreciation portion. All right, let's move on to nominal versus real returns. So nominal returns are the returns that we measure over a particular period of time. When we see we invested $1,000, we had a 16% return. That is a nominal return. A real return is what we get when we adjust a nominal return for inflation. That is to say, we take into account the loss in purchasing power that occurs over the life of our investment. So the quick and simple formula here, hopefully it's quick and simple, is this: 1 plus the nominal interest rate is going to be equal to the quantity 1 plus the real interest rate multiplied by the quantity 1 plus the inflation rate. So if we do this math, we can get what the real rate of return is, for instance. And then this little note here: if the inflation rate is relatively low, then the nominal rate is very close to the real rate plus the inflation rate. All right, and I think we have an example here in Excel, so let's actually jump to that. Go look at the spreadsheet here. So some notes up here in the spreadsheet. The nominal return includes both a real return and an inflation component, and you can see that again with this formula where we multiply 1 plus the real rate times 1 plus the inflation rate would give us the nominal rate of return, 1 plus the nominal rate of return. It's easy to observe the nominal rate, and it's usually not too difficult to measure inflation after the fact. So we can solve for the real rate with a quick little bit of algebra. I'm just rearranging this equation here down in this line 10 of the spreadsheet. 1 plus the real rate is going to be equal to 1 plus the nominal divided by 1 plus the inflation rate. So let's look at a couple of quick examples. Suppose I had an 11.5% return over the last year, and that inflation was 3.2% over the same period. The question is, what was the real rate of return? I can get that exactly by taking the nominal rate, 1 plus the nominal rate, I should say. Divide that by 1 plus the inflation rate, which is what we're kind of recreating this equation right here. And then I'm going to get an answer that is 1 plus the real interest rate. And last step, I subtract out 1. I get rid of the 1 plus. And so I'm left with a real rate of return. And in this case, the real rate of return was 8.04%. Now you might be asking, so what? What's the big deal? Why are we doing this algebra? Why are we doing this math? Well, this is what investors really should be caring about, is the real rate of return. How much better off are they in a purchasing power kind of a sense? How much more stuff can they buy at the end of the investment than they could buy at the beginning? 11.5%, by the way, is not the answer. That was the nominal return, but I can't buy 11.5% more loaves of bread or 11.5% more cars, but I can buy 8% more because of I've taken into account the inflation. All right, let's look at one slightly more complicated example and take into account multiple years. So here I've got a return of 12.5% per year over 4 years, so I've got some compounding going on. And then we're going to assume that inflation averages 3.6% per year over those same 4 years. So we need to compound each of these things and then figure out what the real rate of return is, and yeah, do a little bit of manipulation to get an annual real rate of return. So let's look at the math. It's not too difficult. 1 plus the nominal is going to be 1 plus the nominal rate of return, and we're going to raise that to the 4th power. So this result tells us that over 4 years our total return is going to be a little over 60%. So 1 plus the nominal rate of return. The inflation rate, 3.6% per year, if that compounds over 4 years, that means we've lost a little over 15% of our purchasing power. My formula, I'm going to divide those two things and get this result. 1 plus the real rate of return is 39% or 1.39. My real rate of return, my real return is 39%. Now to get the rate, the annual rate, I need to take the 1/4 root. Why the 1/4 root? Well, because this is a problem looking at 4 years. 4 years of compounding. We're kind of undoing the compounding over 4 years by taking the 1/4 root. And so we get 1 plus the average real return, which leaves us, once we subtract out the 1, with this 8.59%. That's what we earned on a real basis. That was our real increase in purchasing power per year over 4 years, over each of 4 years. Let's go back to the slideshow and see where we are here. Expected returns, and we've got two different ways to think about returns over the next year. So prospectively, looking forward. One is and this is coming up with this notion of an expected return. We can either look at historical returns and look at an average over some period of time and use that to kind of form our expectation of what the next year or the next period is going to look like. Or we can do something slightly more complicated and come up with this thing called a scenario analysis, and that's where we're going to use a weighted average based on some possible outcomes. So this is probably much better explained looking at an example. Let's go back to the spreadsheet and look at some returns. So over here on the left, I've got a series of REIT returns, or real estate index returns. It's not necessarily REITs, but some property index returns. If you invested in real estate, this is what your returns might have looked like over the past 15 or so years. So if I take a quick and simple average of these things, the average over all 15 years is this is actually 16 years. 8.99% is the average there. Let me just show you. Average equals average, and then we're going to highlight all 16 of these things. And we would have 8.99%. So that's the average per year over all 15 years. Sorry, 16 years. Here's a couple of, or actually 4 different ways of looking at some of this data. The average over 2 years, the previous 2 years, has been 12.02%. The average over the last 5 years has been 11.66, The average over the last 10 years has been 7.72, and the average over the last 15 has been 8.81. Now this points out one problem with using an average, in that there's no one right number of periods to use in your average. Here we've got 4 different measures. We could make an argument for each of these 4. You'd have to be left to your creativity to come up with a good argument for which one you should use, but the point is we've got 4 different things. It's not totally clear which one of these is the right one to use. It's always good to, when you're speaking of averages, to let everybody know, hey, this is the average over the last 5 years. And everybody knows that the last 5 years has not included a downturn in the real estate world. So, well, if we look at 11.66%, maybe that's a little higher than we should expect over the long term, because real estate is a cyclical business. All right, so that's a very simple thing. The averages, looking at a time series of historical returns. Slightly more complicated is this thing over here called the scenario analysis, and this would be where I think about some possible states of the economy, some things that might happen over the course of the next year, let's say, and I assign some probabilities to those. Obviously my probabilities need to add up to 100%. If I look down here at this sum of all those cells I highlighted, it indeed equals 100%. And in fact, I set up this cell to force my total to be 100%. You can study this at your leisure. And then I have some expectation. I've put in some numbers that what I think the return would look like if we were in this particular state of the economy. So let's say that we were in a depression. Last time we were in a depression, the return on this particular investment, let's say, was around negative 70%. The last time we were in a deep recession, it was negative 25%. The last 4 recessions we've had, we had an average of negative 8%. This is where these returns might come from. So I've got this series of expectations, and then my expected return over all of these scenarios is just going to be a weighted average. So the weights are going to be these probabilities, and I'm going to multiply that times the return for the scenario. Here is the weight times the return. You can see I'm multiplying these 2 columns together. And then a weighted average is just going to be the sum of all of those products, all of the products between the probability and the return. So you can, let's again just look at each of these numbers. The return, the kind of the component return for a mild recession is going to be the 19% times negative 8. So we have this little negative return. This is going to be a component of our overall expected return. And again, this is just the sum of all of those little bits and pieces. So 2 different ways to come up with an expectation. One is looking at historical data in the past, just coming up with some simple average. And then this one is a slightly more complicated thing. We're going to have different states of the economy. We'll have different probabilities that we assign to them. Maybe we survey economists and we see what do they think the possibility or the probability of a depression is going to be, and 1 out of 100 says, yeah, I think this next year is going to be a depression. So that's where those numbers would come from. The returns, this would roughly correspond to what's happened in the past in those different scenarios, and we just do a weighted average and come up with this number, around 6%, based on the expectations and the returns that we're forecasting. So I'm going to stop there, and we'll hopefully wrap up the Measuring Returns video series with our 3rd video, and I'll see you then.